I recommend that you do one page of like actual notes and then a separate page for the examples, because this is just like solving systems of equations, so it might get a little long. Okay, sorry, I'm just looking through the chat. Looks good, Andre. All right, so today we're talking about matrices and systems of equations. Systems of equations is what we spent the whole last chapter doing, so you guys are well prepared. Let's just drop ahead here. So in the corner, I have boxes where you should write something, whether on your note sheet or examples. Nothing really to write here, but a matrix is just an array of real numbers called a matrix. The plural is matrices. Wonderful. This is what one looks like. They've got rows and they've got columns. Take a second to figure out where a row goes and where a column goes. I know it sounds pretty straightforward, but you'd be surprised. Rows go across, columns go down. The book will say M by N matrix when they're talking about the dimensions. I don't know what M and M stand for, so I'm just going to write row times column. They'll talk about rows first, then columns. So R times C, I would write that down. That's the dimensions of a matrix, and it will just be number of rows and number of columns. So let's say this one, if we just look at the ones that actually have A's, we've got 3 rows, 3 columns. So I would call that a 3 by 3 matrix. What else? These things inside of the matrix that say like A22, I don't like the book's notation. What they're saying is that's row 2, column 2, the entry that's in row 2, column 2. A lot of people, when they just write matrices, they'll just write like A, B, C, D, E, F. I think that's a little bit easier to follow, less things to write down. But the book will say like A11, they're not talking about the 11th term. They're talking about first row, first column. Okay. Here we go. This should go on your example page. Determine the order of each matrix. So what that means, not just order, but dimensions. So write how many rows times how many columns for each one. I'll give you about a minute. Okay, I'm going to start talking through some of the answers. Just keep writing whatever you're writing. That first one, A, has only 1 row and 1 column, so that's a 1 by 1 matrix. B has 1 row, but 4 columns, so that's a 1 by 4 matrix. C, even though it's all zeros, 2 rows, 2 columns, that's a 2 by 2 matrix. D, we've got 3 rows, 2 columns. That's a 3 by 2 matrix. Those ones that have same row and same column is called a square matrix. There's a lot more things we can do with matrix when they're square, and that's just when the number of rows equals the number of columns. Feel free to write that on your notes page if you want. Next one. So this is all we're learning today pretty much. This right here is a systems of equations. You know what that looks like. You've been doing that. That's what your test is going to look like tomorrow. We're just going to solve the same thing in a different format that saves time. So I'm making a matrix. It's got those square brackets like that. Instead of writing X, Y, and Z next to everything, I'm only going to write the coefficients in front of the numbers. Oops. Oh, there we go. So all I'm going to do, this is 1x. I'm going to write 1. Someone asked on the test, can you solve it in this format? Yes, some of you already have been doing this, and it's totally fine to solve this stuff on the test tomorrow like this, if this makes sense to you. So this is, I'm not going to officially write X up here. Like, you don't need to write X up there. I'm just doing that for us. This is going to be my X column. So my coefficients from X in the system are 1, -1, and 2. Next, I'm going to have my Y column. My coefficients for Y are -4, +3, and then I don't have a Y in this third equation. So what that means is my coefficient is 0. I have 0 Y, so I'm going to write 0 there. Then I'm going to write all my coefficients for Z. So that would be 3, -1, -4. Then for the equal sign, in your book, it'll show little dots, but honestly, that's very time consuming, and matrices are supposed to help us save time. So what you can do is just draw a straight line, and that represents our equal signs. And then we're going to write these numbers. These are our constants. So 5 for equation 1, -3 for equation 2, and 6 for equation 3. If you want to, you can write equation 1 here, equation 2 here, equation 3 here, just to show that each row is representing an equation and each column is representing a different variable. So again, this part up here and this part over here, my labels over here, they're not officially part of a matrix. I'm just doing that so we can visualize what's happening. I'm not going to write those going forward. This is called an augmented matrix, which is just a matrix that has this bar for an equal sign. Other matrices, they might not have an equal sign because they might not be representing systems, but this one is, so it's called an augmented matrix. Okay. If we were just looking at the matrix of the coefficients, it would be called a coefficient matrix, but we're not really dealing with that today. I'm going to move forward. This is what you're doing right now as an example. So I'd write it on the page that you're writing all your example problems on. Turn this system into a matrix. I'll give you about a minute to do that. Okay, I'm going to start writing down the answers so you can compare, ask away if you have any questions. Oops. Something to be aware of, if they gave you the equations with the variables in different orders, like if this top one, they gave you y minus 2w plus z equals -3, you need to rearrange all of the equations so you have all the x's in one column, the y's in one column, the z's in one column, and the w in one column. Because I wouldn't want to write 1 as a coefficient here because that's my x column. So don't just do it in the order it's given to you. Make sure you've got everything in alphabetical order first before you copy everything down. Okay. I'm going to move on. If you've got questions, feel free to put them in the chat or interrupt me. We're going to talk about elementary row operations. You already know these. They're exactly the same 3 that we've been doing with systems of equations. You can interchange 2 rows. You can multiply a row by something. Or you can add a multiple of a row to another row. So this is just the same exact thing. If you want to write these 3 down, you can in your notes. But they're already the same 3 that you know how to do with equations. In the next few slides, we're going to look at what those look like, but you don't need to write anything down for the next few slides. They're just examples to look at, and then we'll actually do a problem, and I promise it'll make a lot more sense. Okay. I'm going to move on. Here's an example of switching a row. Literally all they did, they said, I want to replace row 1 with row 2. They flip-flop them. We can do that. Multiplying a row by a constant. They said, I'm going to take row 1 and multiply it by 1/2 so that this coefficient becomes a 1, just like we do with our equations. So that's exactly what they've done, divided each of those by 1/2, and that became their new row 1. Last one, adding -2 times the first row of the original matrix to the third row. So they said, okay, for this third row, I want to add -2 times row 1 plus that row 3, and that's my new row 3. So you'll see when we go through the examples, I'm going to do this work to the side, just like I did there. So I'm going to write -2 times row 1. So that would be -2, -4, +8, and then -6. And I would add row 3 as it is. I just add straight down. This becomes 0. This becomes -3. This becomes 13. This becomes -8. And I'm just going to write that in place of row 3. Something that'll be helpful is to write this notation next to your matrix every single time, just as a guideline for you to go back and check your work. And that's just like standard procedure. Okay, I want to move on so we can do an example, put those into practice. You don't need to write this down yet. We're gonna learn, but you can if you want, we're gonna learn 2 types of solving. One is very similar to what we already know how to do. We want our matrix to have that staircase pattern, but we don't care if there's other numbers there. So this is the first thing we're going to do. This is just Gaussian elimination. Once we get to that step, we'll use back substitution, and we'll turn the matrix back into equations to do that. You can solve these problems entirely without converting back to equations, but just by using matrices. That is going to look like this. We're going to try to get a double staircase pattern. This first one was called row echelon form. This second one is called reduced row echelon form. Once we get into that format, this is just representing one x, so we can say x equals this number, y equals this number, and z equals that number. So those are the 2 methods we'll do today. We'll do it with the same number so that we can see where it comes from. Okay. This you already know. So we're just going to start here. Your first step, change this into a matrix. I'll give you like 20 seconds to do that, and then we'll start. Okay, I'm going to start writing in some numbers. 1, -2, 3, 9, -1, 3, 0, -4, 2, -5, +5, and 17. Okay. My first step, just like I would do if these were equations. If these were equations, I've already got a 1 as my coefficient in the top right corner. That's good. That's fine. This can stay in my row 1, and I never need to change it. Now my whole goal is to eliminate this negative one here. If we were looking at them as equations, I could see that if I just add the two together, row 1 plus row 2, they would eliminate, the x's would eliminate. So that's exactly what I'm going to do. I'm going to take row 1 and add it to row 2, and that's going to become my new row 2. So if I want to, I can do the math to the side. Row 1 plus row 2 becomes my new row 2. So I'm just going to write the numbers from row 1 and the numbers from row 2, add them together. My new row 2 will be 0, 1, 3, 5. So now I rewrite my matrix with that as my new row 2. So I've got 1, -2, 3, 9. That didn't change. And make sure to put in my new row 2, which is 0, 1, 3, 5. And then I copy down my row 3 because I didn't touch that. Okay. Now, this y coefficient is a 1. Perfect. I don't need to do anything with that. That's good to stay my row 2 forever. I don't need to touch that. What I want to do now is eliminate the 2 down here. So see if you can figure out what you need to do in order to eliminate that 2. You do the same thing as you would do if there were equations. So I'll give you a minute while I go check on them taking their test and go through this. See if you can get to a point where you have that staircase, 1, 1, 1, and zeros in front of them. So see if you can do that. I'll be back. Should have -2 times row 1 plus our row 3. That should be your next step. -2 row 1 plus row 3 to become our new row 3. Okay. So -2 times row 1 gives me -2, +4, -6, -18. My row 3, I'm just going to copy it as it is. I should end up with 0, -1, -1, -1. So I'm going to rewrite my matrix one more time. I keep row 1 and 2 the same. I change row 3. Now I need to eliminate this -1. I see if I just add row 2 from above to row 3, they'll cancel out and give me a 0. So I'm going to do that. Row 2 plus row 3. Add them together. 0, 1, 3, 5, 0, -1, -1, -1. Add them together. 0, 0, 2, 4. So I end up with this matrix. I'm going to write it one more time. 1, -2, 3, 9, 0, 1, 3, 5, 0, 0, 2, 4. And then just to save space, although if I were you, I'd write it again. I'm going to divide multiply row 3 by 1/2. So that brings those two numbers to 1, 2. So now we've got that stair-step pattern. Very nice. Looks good. At this point, this is where we could break off into either of the two options. We can do back substitution, which we'll do first, or we could go eliminate all of these 3 variables in order to get that nice reduced row echelon form. we're going to do back substitution this first one, and then we're going to come back to this exact same matrix and do reduced row echelon form, and we'll see how we get the same answer. So to start with back substitution, I need to change these back into equations. I can't do it using the matrix. So this bottom equation, that's 0x plus 0y plus 1z equals 2. The second equation, that's 0x plus 1y plus 3z equals 5. That top equation, you can figure that out on your own. So what you're going to do is just use back substitution, just like you would with the equations. When you're done with that, type your answer into the chat in a private message. I'll let you know if it's right or wrong. I'll give you guys about 2 minutes to do that. Should be getting z equals 2. That one's a given. I plug that in here. Y plus 6 equals 5. If I subtract 6 from both sides, I should get y equals -1. That last equation will be x minus 2y plus 3z equals 9. So I've got x minus 2 times -1 plus 3 times 2 equals 9. Once we solve that, we get x equals 1. So we can write our answer as an ordered triple, 1, -1, comma 2. Nice job, Vivek. Okay. I'm going to move on, but what we're doing, I'm just starting from this last matrix we have. So I'm going to copy and then paste. This is the same one we found. So now what our goal is to get these 3 0. We want to eliminate those 3. So what we did, our first set was like we were going down, eliminating this, then this. Now we're going to go up. I'm going to use this bottom row to eliminate the 3. Then I'm going to use the bottom row again to eliminate the 1 up here. And then I'm going to use the middle row to eliminate this -2. So that's where we're going with this. Let's see how it works. So if I want to eliminate this 3, I need to take a -3. I need to multiply this row by -3 and add it to row 2. So it's going to be, oops, I'm not kind of out of room, but what I want to do is take -3 row 3 plus row 2 and make that my new row 2. Let's do the work over here. -3 row 3 plus row 2 will become my new row 2. -3 row 3 is going to be 0, 0, -3, -6, and then I'll just add row 2, which is 0, 1, 3, and 5. Add them together, I get 0, 1, 0, -1. So that's my new row 2. So I'm going to write that below. I keep my row 1 the same. My new row 2 looks like this. And I keep my row 3 the same. Okay. Let's take row 3 again and use it to eliminate this 3 up here. So if I take -3 row 3 and add it to row 1, I'll get a 0 in that spot. So I'll have -3 row 3 plus row 1, and that's going to be my new row 1. -3 row 3 is the same as it was before. Row 1, I'm just copy pasting, and then I add straight down. 1, -2, 0, -6 and 9, we get 3. So this is my matrix right before the end. This is the second to last step. My new row 1 is 1, -2, 0, 3. and then I copy row 2, then row 3. Last step, you try it on your own. Eliminate this -2. Use the row right below it to eliminate the -2. We should have taken row 2, 2 times row 2, add it to row 1, and replace row 1 with it. So 2 times row 2 plus row 1 becomes our new row 1. 2 times row 2 is 0, 2, 0, -2. Row 1, I'm just copying and pasting. My result is 1, 0, 0, 1. So my final matrix is 1, 0, 0, 1, 0, 1, 0, -1, and then 0, 0, 1, 2. From this, what this is saying, because this is my X column, this is my Y column, this is my Z column, I know that X is equal to 1, Y is equal to -1, and Z is equal to 2. So it's the same exact answer we got before from using back substitution. I honestly think this way is nicer, but you have to know this way because if they ask you on the test, you need to be able to make this matrix. You'll also see this reduced row echelon form come up a lot when it gets more complicated. So we need to know how to make a matrix get into that form. We can have no solution. When we have no solution, that means you get a row in your matrix that has all zeros on the right-hand side, and then some number. It doesn't have to be 2, it could be 0.5, it could be 7, it could be 100. If we have zeros all the way on one side, our augmenting equal sign, and then some number, that's exactly like when we have solutions and we get 0 equals 2. That's false. That means no solution. Oops. So I'm going to write here, no solution. If you get 0, 0, 0, and another 0 for one of your rows, that means we might have infinite solutions. So that's exactly like when we get 0 equals 0, and that's a true statement. We'll have infinite solutions. Another time when we have infinite solutions is when our rows, the number of rows we have is less than the number of columns we have. So I'll give you a quick example for that one. If we have 2x plus 4y minus 2z equals 0, 3x plus 5y equals 1. We know from equations there's going to be an infinite amount of solutions because we have more variables than equations. But go ahead and turn this into a matrix because we're going to do this example fully. Go ahead and turn this into an augmented matrix. Okay, so we should have 2, 4, -2, 0, 3, 5, 0. We have to put a 0 there. We can't just leave it blank. 1. Okay. We're going to try to solve it into staircase form as much as we can. So that means I want this 2 to become a 1. I want the 3 to become a 0. And I want the 5 to become a 1. So in order to get that 2 to become a 1, we need to multiply row 1 by 1/2. So our new matrix will just be 1, 2, -1, 0. I'm keeping the bottom row how it is. In order to make that 3 become a 0, I need to take negative 3 times row 1 plus row 2. That's going to become my new row 2. So I can do that work over to the side if I want. Negative 3 row 1 plus row 2 becomes my new row 2. So I'm going to have negative 3, negative 6, positive 3, 0, plus 3, 5, 0, 1. I end up with 0, negative 1, 3, 1. So I keep my row 1 the same, but I put my new row 2 there. Last step, I need to multiply row 2 by negative 1 and make that my new row 2. See, if I were you, I'd rewrite the whole thing, but I'm just going to change the signs on everything to save room. Okay, at this point, we've got a staircase going here, but there's no room for us to continue the staircase because we don't have another row. So at this point, you have to use back substitution. You need to turn it back into equations. You cannot continue on with matrices. So I'm going to rewrite those as equations. That bottom one is y minus 3z equals negative 1. And that top one is x plus 2y minus c equals 0. At this point, it's exactly the same as when you have infinite solutions with a system of equations. So we're going to take z and set it equal to a. Go ahead, find your y equals and find your x equals from those two equations from there. Once you have your answers, put them in the chat. I'll tell you if you're right or wrong. If you're right, you can go. That's the end of the lesson for today. Make sure though that after you leave, you submit your notes and your examples to Canvas as an assignment. Yeah, so someone asked, can I repeat what z equals a means? So when you get infinite solutions, that doesn't mean that everything in the world is a solution. That means that there's specific solutions on some sort of pattern. So we need to find that pattern. So what we do is we start with z equals a. We just do that so that we have some variable that's outside of x, y, z. So once we get to a point like this in our matrix where we can't go any further, we need to set z equal to a. Then we plug in that a for z into the equation that has only y and z. And then I solve for y equals. So I move everything over to the other side until I have y equals. So that's your first step. So those of you who are still struggling, see if you can do that. I'm gonna do this on a blank sheet of paper. What did we have? Our equations were x plus 2y minus z equals 0 and y minus 3z equals negative 1. And we said, okay, z equals a. So then we plug that into that second equation. I solve for y equals, and I get y equals 3a minus 1. I think you're all there at that point. Then I do x plus 2 times 3a minus 1, because I'm plugging that stuff in for y. And for z, I plug in a. So now I need to distribute. I have x plus 6a minus 2 minus a equals 0. So if I combine like terms, I get x plus 5a minus 2 equals 0. But I need to get those over to the other side. So I need to subtract 5a from both sides. And I need to add 2 to both sides. So I end up with x equals negative 5a plus 2.